Hi everyone. Today we're going to talk about MATLAB Simulink, which provides us with a graphical user interface to build our system using building blocks that we can easily drag and drop to our main menu. In order to do that, we will start from the Simulink link on the top menu. You could also type Simulink in the command window, and when you click on that, you have different templates. You start from the blank model, and we have the blank model over here. Let's save this, and I have the folder ready as MATLAB inside my documents, so I'm just saving this as test Simulink. So after that, we need to bring some building blocks using the library browser. So when I click on that, there are different options that I can choose from on the left side. So when I'm opening the Simulink, I have different tabs that you can open, like commonly used blocks, continuous blocks, discrete blocks, and you can drag and drop each one of them. First of all, I need to bring a transfer function that I can take it from the continuous. If I scroll down, here's the transfer function block that I can drag and drop. Then we need a scope that I can take from sync. So close this, go to syncs, and we have scope. And then we need a step function that I can take it from sources. So sources, and I scroll down, there's a step function. We may need to have some gain and sum blocks that we can get it from math operations. So let's go for math operations, and we can get gain or sum block. You can find it here, as well as a mux block from signal routing that combines all of them. Because here that combines several signals and feeds that to the scope on the right side. So that's pretty much it. Most of these ones are also found in the commonly used blocks at the top. If not, you can search more or enter the searching item term here as well. So in this example, we don't need this gain block, so I'll delete that. But we're going to build a simple transfer function based block and analyze its behavior in the system and view the result using the scope. So let's consider that this is our main system. We can make a feedback transfer function using the same transfer function block that we already have dragged upon the main menu. We just need to copy and paste that. And in order for us to flip this new sensor transfer function at the bottom, we just need to right click on that and go to format and then flip block, or Control I also helps us to flip it. And as you can see here, the entrance to this block is from the right side and the exit is from the left side. Now we just need to connect them as an example. So you can drag and drop a line from the exit of a block and to the entrance of another block to just connect them. You can keep doing that from, say, the output of this error block to this transfer function, and then from transfer function to this mux, and then from mux to the scope. You can have a feedback from this output of the system and all the way to this summation box. In order to make the summation box as a negative feedback, you need to just double click on that, and then when it says list of signs, you have positive, positive. Just remove the last one and then enter negative. Just click OK, and it turns into positive, negative. In that case, you will have a negative feedback. Now you can label each building block with just click on that, and then the default name shows up, and then you can click on that and change that. We'll like to call this as system. The bottom one is our sensor, we have this scope on the right side as system response, and the start one is step input. Then we can also call each node as we wish with just double clicking on that. That allows us to type, for instance, output here. Then we can type measured output on this line. We can also make the mux a little bit larger in size. So number of inputs could be 4 in this case, and type an OK. You can then drag it on each side that you wish. Since I'd like this to go to the third input, I just can drag it and connect to the third input. Then I can connect the second input of the mux to this node that essentially is the error node. Then the first output can be on the step input, which I can call it as set point. And then the last one could also come from the measured output. And I can bring it down. Okay, so this is our main system. We'll save that every now and then to make sure that everything stays safe. Okay, so now that actually we have entered everything in our system, we can modify each building block by just double clicking on the building block. As you can see here, the transfer function now shows 1 only in the numerator as the coefficient, and also 1, 1 in the denominator. We could also change them manually to 8, for instance, and apply it and see that immediately it shows itself over here. And click OK, for instance, for the time being. Now, if I want to not to manually change all of these parameters, we need to define some variables. But in order to do that, we need to make an M file and save it in the same location that this building block is already saved. So let's go for MATLAB. And we have our directory on the left side. So we need to create a new script. And I would start by saving this. Save as in the same location with variables.m. And in this case, as you can see, it shows up on the left side. What I need to do here, I would add some lines of clear all and close all. The first one actually clears all of the variables that have been studied in the past, and also closes all of the open windows and figures. And what I need to do is, in order to create a first order system, we need to have k as the factor that shows up in the numerator. I would call it the capital K that equals 1 in our case for the time being. And I need a tau, which is the time constant of this first order system and shows up itself in the denominator of the first order. I would then call this as tau equals, for instance, 8. Then we can have some comments over here as well. Seconds, 8 seconds in case the magnitude. We can then save this file. Now that this file is saved, it stores all of the variables that we may use in our system as k and tau. Then we'll need to recall this file, this .m file, in our main building block. So let's go back to our main building block. So our main Simulink block is over here, and in order to recall that, we need to go to modeling and then model settings and then model properties. And over here there is a callback tab that we need to enter the name of that .m file in post load function as variables, and only the name is enough, it's not .m, and also the init fcn or initial function variables over here. So apply, make sure that it is on both tabs. Once everything is done, we need to then move on and change this parameter here In the numerator we'll have k, and in the denominator we'll have tau that demonstrates the k and tau of the first order system. Apply and then OK. So now we're set. On the top right side, in order to simulate the system, we'll change the stop time from 10 to 40 to demonstrate 40 seconds. And then we're ready to run the system. So the system finished simulation, and in order to view the results, we need to double click on the system responses scope on the right side. As you can see here, we have the results of all of the outputs that we have annotated, and in order to view them separately, we need to bring the legend. In order to do that, we'll go to view and open the legend. And as you can see here, we'll have the set point, error, output, and measured output. This is the first order system that is run by step response, as you can see here, with a yellow line, and the output is shown with an exponentially increasing function in red. And the error of the system, that was output of this summation block here, is shown with this blue line, as well as the measured output is shown with the green line. So that's pretty much everything about how to start using Simulink in order to demonstrate the response of a system to a single order system with respect to a feedback. Hope you already have liked this. If you like such videos, please subscribe to the channel and hit the like button. Thank you and see you soon.